Hello guys, welcome to Data to Info. In today's video, we will look at Numpy in Python. Okay, so in this series, we will continue with data analysis and data science using Python. We have already covered the basic and intermediate level Python videos. This is a third video in this series. So let's get started. What is Numpy cheat sheets? Alright, so this is a cheat sheet, so don't expect me to cover each and every topic. What is Numpy basically? Numpy is a library that is numerical Python library. Numpy means numerical Python library. Is a core library for scientific computing in Python. It is core library for scientific computing in Python. What does that mean? It basically means for high level operations for computations like matrix computation or arithmetic operations. You can use Numpy arrays. So mostly here work deals with arrays and lists, right? One-dimensional array, two-dimensional array, three-dimensional array, likewise. It also provides a high performance and multi-dimensional array objects, right? The tools for working with these arrays, it also provides those as well. So this is what the Numpy in Python, right? So how do we define it? So before defining it, let me show you the list that we saw earlier. This is the Python for data science cheat sheets. So we already covered two videos from Python basics, part 1 and part 2 already. Now this is the third video in this series for Numpy basics. So let's see the Numpy cheat sheets. Alright, real quick. How do we how do you import Numpy? We write import Numpy as NP. NP is an alias. You can use any other alias as you want, but I'm using NP. We are going with the recommended thing. Now there are mostly you can deal with three types of array. You can say 1D array, 2D array, 3D array, right? 1D array comes with only one axis. 2D array comes with two axes, means row and columns. The 2D axis forms a matrix, right? 2D array forms a matrix. Now there is a 3D array as well. It will involve three axes, right? So let's create the Numpy array. Let's create the Numpy array for 1D, one-dimensional array. How do you create a one-dimensional array? np.array. There is a method called array, right? Inside which you can write the array in square brackets. Let's say 1, 2, 3, right? Now this is a array. You can store this array in a variable. Let's say I want to store this in a variable A. So what it will become? It will become array A, right? Numpy array A. Let's create a 2D array as well. Let's create the 2D array as well. In 2D array, what we can do? 2D array is a matrix. It covers two axes, right? As I told you, rows and columns. So let's store this 2D array into the variable B. Similarly, np.array method to create an array, right? Inside which inside square bracket, you have to provide two parentheses separated by comma. In each parenthesis, you can put the variables and values 1, 2, 3, 4, 5, 6, likewise, right? Is it fine? Yes. Now you can print it as well. See, it has two rows and three columns. How do we know it has two rows? Because it has two parentheses inside it, means it has two rows and three columns. Each parenthesis have three elements, means it has three columns. So it is 2 by 3 matrix. Right? Let's create an array of 3D, means 3D array. 3D array is a collection of 2D arrays, means collection of matrices, right? So let's create that 3D array. Let me store it in a variable C. np.array into square bracket. Now this is the first square bracket, right? Inside this square bracket, I have to give, let's say, two different square brackets separated by comma. Inside each square bracket. Now this inside the square brackets are considered as layers. Now these are two layers. Inside two layers means I have to give two rows. See, like this, separated by commas, using parentheses. And now I can give the elements, let's say 1, 2, 3, right? 4, 5, 6. Let's say 3, 2, 1. And over here, 4, 5, 6, right? So this is one way to do it, right? You can specify data type. Let's say I don't specify data type and I just print it. So what will happen? It will take a default data type. You can specify the data type as well. Let's say I want to put it as a integer, or I want to give it as the type is equal to int or float. You can do this like this, but let's keep it as int only, integer, right? So this is how. Now, how do we read this 1D array, 2D array, 3D array? Let me show you the shape of it. A dot shape. There is a shape method, a dot shape. The shape of 1D array, that is A, is 3, means it has only 3 rows and no columns. 3 rows and no columns. What about the shape of, let's say, B? What about the shape of B? B means second array. It has 2 rows and 3 columns. It has 2 rows and 3 columns. See, it has 2 rows and 3 columns. 2 rows and 3 columns like this. What about the array C? That is 3D array. 3D array will give you something like this. It gives you 3 values. Now, how to read these 3 values? See, the first value is a layer. How many layers are there? The second value is row. How many rows are there in that layer? Third value is a column. How many columns are there in that layer? So, first value is a layer. So, let's see. There are 2 layers. The first layer is this one. The first layer is this one. The second layer is this one. Right? And in each layer, there are 2 rows and 3 columns. In each layer, there are 2 rows. See, these 2 rows and 3 columns. These 2 rows and these 3 columns. So each layer has 2 rows and 3 columns. So this is what the 1D array, 2D array, and 3D array looks like, and its shapes. How do you see the dimensions? Like how many dimensions each array has? So you can use a dot enddim method. Means write the array name dot enddim, means number of dimensions. How many number of dimensions are there? In array A, there is only 1 dimension. In array B, there is 2 dimension. The array C, there is 3 dimension. See? So this is how you can figure out the dimensions. Let's see about the placeholders. Let's see about some placeholders. Initial placeholder. Initial placeholders. Can we create, what is my placeholder? Means there are some inbuilt methods to create array. Let's say I want to create array filled with only zeros. There is a method called zeros. How do you access it? np dot zeros, np dot zeros, and you have to give number of rows and number of columns. Let's say I want 3 rows and 4 columns. 3 rows, comma 4 columns. So you will get an array of 3 rows and 4 columns filled with only zeros because it is zero method. Can we return an empty array? Can we return an empty array using this zero method? Yes, we can do that. We can return an empty array. Let's say we are creating an array of np dot zeros, inside which I want 1 row but 0 column. I want 1 row but 0 column. It will return an empty array. Let me print it as well. See, it is returning me an array because I wrote 1. So it will have 1 row, but there is nothing in it, 0 columns. So means no value inside this array. See, empty array. This is how you can show the empty array. Can we create an array which contains only 1? Yes, create an array of ones. np dot ones. There is a method called ones, np dot ones. 3 rows, 4 columns. You can put it like this and it will show you the array. Now it is by default giving me float value. You can change it. The type is equal to, let's say, np dot int 16. This is a data type. I will tell you about the data type later. So you can describe the data type like this as well. Now it will be only integer. Values containing only ones, right? So there is a method called zeros. There is a method called ones, right? These are the placeholders. Now there are another method called arrange. Here another method called arrange. What that arrange method do? It creates an array. It creates an array of evenly spaced values. Of evenly spaced values means step value. I will show you what is step value is. Let me create an array of d np dot arrange. np dot arrange. Inside arrange, I have to give three arguments. What? First argument is start argument. Let's say I want to start with 10. The last argument is, let's say I want to give 26. So I will create an array between 10 and 26, right? And the third argument is step. This is called the step value. Let's say I want every value to be differ with 5. This is the step value. You can give step value anything. Okay. Start value, end value, and step value. See. You can run it like this. So it will start with 10 and difference between this current value and the next value is 5. Right? Because we give step value as 5. So difference between two values is 5. So 10, 15, 20 and 25. Right? So it won't exceed 26. It will under the 26 only. Right? Till 26 or under 26. Right? So this is how it is. Arrange. It has 3 arguments. First is start value. Second is end value. And third is step value. What? Step. S-T-E-P. Step value. Right? Very good. There is another way to create an array of evenly spaced values, but instead of step value, we use number of samples. Instead of step value, we use number of samples. See, and the method that we use to do this is linspace. L-I-N-S-P-A-C-E. L-I-N-S-P-A-C-E. Linspace. Inside linspace, you give the same thing. Let's say I want to start with 0. The end value is 2. And the evenly spaced means third value is not the step value here. Now here the third value is the number of samples. Now how many number of samples you want in your array, you can limit that as well. Let's say I want only 9. Only 9 elements. See, so this linspace, what it will do, it will give you only 9 elements from 0 to 2. See, you can count it 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So this is how you can create an evenly spaced array. You can create an array with a constant only. You can put any constant value in an array. Let's say we create an array of E is equal to np dot full. Now the full method will help you to create an array of constant only. Let's say I want to create a 2 by 2 array. Okay. Comma after the bracket. Let's say I want the value inside the array is nothing but 11. So, see, you will get a 2 by 2 array with the 11 value inside it. Now, this is the constant value, right? So, you can put any constant. This is how you can create a constant array. You can also create an identity matrix, right? Let's say we want to create an identity matrix of 2 by 2. F is equal to np dot eye. You have to create it using a method called eye. 2 by 2, no, not 2 by 2. Let's say we create a 3 by 3 matrix to better understand it, right? Identity matrix, right? So see, identity matrix, what is meant by identity matrix? Means all diagonal elements of that matrix is 1 and all other elements are 0, right? All the elements of identity matrix is 0 except diagonal matrix. Diagonal elements of the identity matrix is 1, right? So this is identity matrix. Can we create an array with random values? Yeah, we can create an array with random values using random method. np dot random dot random. Now 2 times we have to write this random dot random, and after that we have to give this shape. Let's say 3 cross 3. I want to create a random matrix, and it will give you the values from 0 to 1. Random values from 0 to 1. You can use this kind of placeholders for arithmetic computations or scientific computation where you need some values inside your matrices so that your calculations won't stop, right? You can create, there is a method, empty method as well. You can create an empty array with empty method as well. But this empty method, what it does, now see, there is a very good question. If you have empty method, why do you create an empty array with a 0 method, right? because this empty method will not have anything. It's not like that. It will have something in it. Let me tell you what it will have. Now this empty method contains the data of arbitrary values, contains uninitialized arbitrary values. What does that mean? It means your Python has garbage collection, right, for memory management and all. So it will collect any random values from your memory. It will collect those random values from your memory, your garbage collection, and put it on the matrix. Put it on this matrix randomly. The random value it places randomly. So this is what it does, the empty function. Okay. Let's go ahead and do some IO operations. Let's go ahead and do some IO operations. IO operations mean input-output operations. How do we save something on a disk? Let's say you want to save some array on a disk or load some array from the disk. How do we do that? Let's say we have this array A that we created earlier. It contains value 1, 2, 3. And I want to save it in my disk. You can use np.save method. You can use np.save method. Give the name of the file. Let's say my underscore array. My underscore array is the name of the file. Comma, give the array. Give the array name. This is array name A, right? So I'm saving this on a disk. I'm saving this on a disk. Now this, after execution, the file with my underscore array name contains the array A, the Numpy array A. Now we can load it back using np.load method. Using np.load method. You can call it by their name, my underscore array. Dot other extension is npy, numpy array, right? So npy. See, it is getting loaded back from your disk only, right? Very good. Can we save multiple arrays? Yes, we can save multiple arrays using method saveZ, like this np.saveZ. You can give the name array.npz. Let's see, array.npz, comma. Let's say I want to store A is equal to A and B is equal to B. Yes, two different arrays I want to store. You can do that. How do you load it then? You can, let's say, np.load, inside which call the array.npz. See, now it will return you an object. So how do you show it? You get out of object by creating a variable function. Let's see, we create a variable function, loaded arrays. Now you can use this variable function. To show something. Let's say I want to show the first array. Write the first array name A, right? See, the first array name you can put and show the arrays. Similarly, you can do it with the second array as well, right? So this is how it is. What about text file? Can you save and load the text file? Yes, there is a method called np.loadText, np.loadTxt, inside which you have to specify the file name, and you can store, or let's say I'm creating a file or loading a file which has some values already. So let me show you something. I have the file called my.txt. See, I have the file called myfile.txt. It contains some values. And now that value I can load from over here. Load txt method. myfile.txt. See, all the values from that file will get loaded. So you can do that as well. So remember this method, load txt method. Okay, very good. What about data types? I told you about data types. What kind of data types we have inside NumPy? Let me show you. We have np.init64. 64 is a bit. Means 8 bytes. So np.init64. int, not init, sorry. np dot int 64 bit, right? There is np dot float. You can use 16-bit, 32-bit, 64-bit float, right? So it has the computation power accordingly. As many bits it gets increased. There is a complex as well. np dot complex. You can go with 128 bits. Right? There is np dot boolean as well. np dot boolean 8. There is object data type as well. np dot object, right? There is a string data type and Unicode data type as well, so you can figure it out. So this is how the number of data types are there, right? And in a array, you can put one type of data only, because Numpy array is a homogeneous array, not a heterogeneous. Okay, you can't put integer, float, string at the same time, right? If you have integer, it will contain only integer. If you have float, it will contain only float, right? So likewise, it is homogeneous, not heterogeneous. It contains one type of data only. So remember that. How do you inspect an array? Now this is very, very important to inspect an array. Alright. So how do we inspect array? After that, we will see some of the arithmetic operations as well. So let me give you the name. Inspecting arrays. So I told you about the shape method, right? So array name dot shape. You can figure out the shape of the array. The shape of the array B is 2, 3. There is a method called length. You can figure out the length of the array. Length of array, let's say A, is 3. Means number of elements inside the array is 3. This size of the array, basically. I told you about the dimension and the, right? It told you the dimension. What about size? Let's say E dot size I do. Now it will give you the size of the array as well. So length and size does the same thing, right? Length and size does the same thing. What about, let's say, let me show you the B6. See, number of elements, size give you the number of elements. The length of B over here gives you 2. Okay, so length will give you only the number of rows. It will have, if it is 2 dimension, right? If it is 2 dimension or more. But let me show you the C, length of C over here. So it will also show you 2, because the number of layers it will showing me. So in that case, if you want to figure out how many elements are there, you better use size. B dot size. Very good. Can we convert an array to a different type? Yes, we can convert an array to a different type. Let's say there is a array name B dot. You can use the method called as type. ASTYPE, as type. Int 64. See, you can give the data type name as well, like this, for any array, and change the data type. Means convert an array to a different data type. Right? Very good. Let's see some arithmetic operations. Okay, let's see some arithmetic operations on Numpy array. We have an array called A, which has 3 elements, right? We also have an array, a 2-dimensional array B, right? Can we subtract this to array? Can we do a subtraction on this to array? Subtraction. Let's say I want to provide the variable G, A minus B, right? So I am going with minus sign over here, right? And there we go. We have 2 arrays subtracted using arithmetic operation minus. There is a method called subtract as well. You can use that as well. You can call it using np dot subtract, and you have to provide 2 arrays A, B. You will get the same effect. You can do addition as well. How? Let's say b plus a. See, addition of elements. There is a method called add as well. np.add method. You can provide two arrays like this, and you will get the same result. There is a method called divide as well, but let me show you the normal divide using slash a divide b, right? And using divide method np.divide, you can provide a comma b. You can provide a comma b as arrays, and the elements will get divided. There is a multiply method as well, but you can also give multiply like this. You can also show multiply like this. And there is a method np.multiply a comma b. See, multiplying the elements of two different array. Now there is exponentiation method as well. np.exp means exponentiation, e raised to the power. Now every element, let's say every element of array b will get exponentiation like this, e raised to the power, right? Very good. What about the square root? Do we have any method for square root? Yes, there is a method for square root called sqrt, square root. You can go ahead and find the square root of every element of an array. Now there is a method called sine, log, cosine to find the values of sine and cosine of every element of an array. Let's like this, np.sine of a, right? np.sine cos of b, likewise, right? Logarithmic values you want, np.log of a, np.log, sorry, not log of a, right? Now there is an what we can multiply it using dot method as well. Now I show you this multiply method, right? But there is another method to multiply two arrays. E dot, let's say I want to multiply e with f, using dot method, provide f. See, okay, now the shape is not there. Let me show you the f method. I think f method is not, I haven't created. Let me create a f method first. F is equal to np dot, let me create identity matrix, real quick, 2 cross 2. Let me create identity matrix of 2 cross 2, right? Okay. Now I can give multiply using this dot. See, this dot function multiplies two different arrays of the same size only, but this dot multiply method will multiply two arrays of different size, right? So this is the difference between these two methods, and this is very good interview question as well. What is the difference between np dot multiply and dot method, right? Okay, now let's do some comparisons between arrays. Can we do some comparisons? Okay, let's do some comparisons. Element wise comparison you can do. You can check if elements of A is equal to elements of B, and the places where the elements are equal, row wise, it will show you the true, and at the other places it will show you false. So true and false, it will give me the answers, right? True and false. You can show like this, greater than less than 2 means it will go ahead and apply this equation on every element of array A and return true and false result, right? Whether it is less than 2 or not. There is a method called array underscore equal. You can compare two arrays and see if it is exact equal or not. np dot array underscore equal A comma B. See, false. So two arrays A and B are not exactly equal. So that's why it is giving me value false. If it was equal, it would have given me true. Answer as true. Alright, okay. Let's go and do some aggregate functions. Let's go and do some aggregate functions. Aggregate functions is also very, very important in terms of calculations. Aggregate functions. So let me show you the array first, array elements. The array A is this. You can sum the array using sum method. There is a method called sum. Pardon me. Okay. So there is a method called sum, right? Now you can count the frequency of a given element or given value appearing in Numpy array using bin count method, like this np dot bin count of A. So it will tell you like this. It will tell you that which element comes how many times, which element appeared how many times in an array. So it starts from 0. So 0 occurred in array A as 0 times. So it will show you 0. So 1 occurred in element A is 1 time. 2 occurs is 1 time. 3 also occurred as 1 time only. So it will show you each element occurred how many times into the array. It starts from 0. So bin count. You can use bin count method. And there is a method to find the minimum of an array. Let's say a.min. There is a method called a.min to find the minimum of an array. Right? You can find the maximum of an array as well. Let's say there is this is our array B, and let me find B dot maximum around axis is equal to 0. I want to find the 0th axis element around 0th axis. The maximum from array B will be like this. This is the maximum row. Right? Row wise I want to find. Right? Very good. Sorry, the column wise I want to find. So this is what the column wise means axis is equal to 0. Can we find the cumulative sum of an element? Yes, cumulative sum. What is cumulative sum means? Let me show you. B dot sum around, let's say, axis is equal to 1. Axis is equal to 1. So see, this is the cumulative sum. The first two values will get added, and the sum of it will get added to the next value, and the sum of that will get added to the another next value. Likewise, the cumulative sum happens. So 1 and 2 will be 3. The 3 plus 3 is a 6, right? So for every row, it is happening the same way. This is what the cumulative sum is. Can we find the mean? Mean means average. Can we find the mean of an element of an array? Yes. This is an array A. Let me find the mean. np dot mean. See, the mean of an array A is all elements of an array A is 2. So mean calculates the arithmetic mean or arithmetic average of an array elements along a specific axis. Alright, very good. Can we find the average? Now there is an average method as well. Now mean and average, it does the same thing, but there is a difference. Let me show you the difference. np dot average. Average of A. Now see, the mean method and average method does the same thing, but there is a slight difference. The mean method calculates the arithmetic mean of an element, but the average method calculates the weighted average of one array elements. What it does, it calculates the weighted average. So you have to provide the weights. If there is some weights, you can provide it over here, right? Stored in an array or something like that. But without weights, if you don't give weights, it will act like a mean method only. The average method will act like a mean method only if you don't provide weights. But why do we provide weights? The weights are getting provided to adjust the distribution of elements in an array. Alright. So let's go and see the median of an array. np dot median of B. See, the median of array B is 3.5, the middle value, right? That's what the median is. You can find out the correlation coefficient and standard deviation of an array. Let's go and find correlation coefficient. NP dot correlation coefficient of an array means relationship between two different arrays. Relationship between two different arrays is a correlation coefficient. Thus, two different arrays is related to each other in any manner. You can find that out, right? This is what the correlation coefficient does. All right. What about the standard deviation? np.std. There is a method called np.std. Let's say I want to find the standard deviation for B, for array B. Now this is the standard deviation. What standard deviation value tells us? Standard deviation value tells us how much the distribution is deviated, the data is deviated, means separate or away from the mean value. Now this much it is away from the mean value. That is what the standard deviation shows you. All right. Let's go ahead and see something about copying an array. Can we copy an array? Yes, we can copy an array. Let's create a view of an array. Let's create a view of an array A. Now there is a method called view. View means a temporary copy of an array. It's a temporary copy. It does not store permanently into the disk. Okay, it's a temporary copy. View. Alright, view of an array. There is a method called copy method as well. You can create a copy method. See, h is equal to np dot copy. This is a copy method to create a copy of an array. Let's say array A. Right? So array A getting copied like this. Now this is a shallow copy. Let me show you the deep copy. How do you create a deep copy of an array? And I will tell you the difference between shallow copy and deep copy. Now just changing the adjustment of array placement, you can switch between shallow copy of an array and deep copy of an array. This is a deep copy of an array. What is the difference between shallow copy and deep copy? Let me show you about the deep copy first. The deep copy, if you change anything into the copied object of a deep copy, it won't change anything into the original object. Okay. But in case of shallow copy, if you changed or update anything into the copied object, elements of a copied object, it will replicate it into, or it will change in the original object as well. So that is the difference between shallow copy and deep copy, right? So this is very, very important in terms of interview perspective questions. All right. Okay. Let's go and see some methods about the sorting an array. There is a method called sort. To sort an array in ascending order. It is already sorting ascending order. Alright. Let me show you the B then. I think B also is sorted in ascending order only. Yeah. So you can use the sort method anyways. You can check some subsetting, slicing and indexing as well. So let me show you some subsetting for subsetting. How do you figure out the subset of an array? Now this is an array A. I want the subset of an array. I want to access the last element, like this 3. You can give the index as well like this. By providing the index in a square bracket, you can find the subset of an array. Right? Now this is an array B, right? The elements of an array B. How do you say the subsetting of array B? B square bracket from 0 to 2. I want the element between index 0 to index 2. That is 3. So 2 minus 1, it happens always. 0, 1, 2. So this value will get selected, right? Means 0 column. This is 0 column. 0 row, 0th row. And second column, 0th row and second column. 0, 1, 2. The second column. It starts from 0. This is how you can access the subsetting of an array. Can we do slicing? Can we do the slicing of an array? Yes. Let me show you the slicing of an array. The slicing of an array looks like this. 0:2. See, slicing of an array. We starts from 0th element and go till 2 minus 1. Means 2 minus 1 index. Right? Means first two elements will get printed. Right? Can we select items, let's say from row 0 and 1 from column, from array B. Let's say there is an array B. How do you do the slicing? 0, 2, 1. Now, how do we read it? We are selecting items at row 0 and 1. At row 0 and 1 in column 1. In column 1. See. Like this. Right? Can we select all items from row 0? Yes, we can do that. We can select all items. We have to write colon and only 1. See, means all rows. Can we reverse an array? Now this is a very, very interesting question. Can we reverse an array? Yes, we can reverse an array using double colon minus 1. Double colon minus 1. Last use minus 1 means till last element you can reverse an array. See, earlier it was 1 to 3, now it is 3 to 1. Right? There is another method to reverse an array, but it is not mostly used. np dot flip ud. Ud means up or down. You can flip the array. You can flip the array elements up or down. See, this is how you can flip the array elements up or down. Flip ud. Alright? Very good. Let's go ahead and do something array manipulation operations. Let's do something array manipulation operation in NumPy. In NumPy. Array and See, can we transpose an array? Yes, we can transpose an array using n dot transpose. There is a transpose method. You can transpose an array, let's say B. I want to transpose an array B. You can do this like this. Let me store it in a variable I for future reference and show the I. The transpose means the rows will get to the columns and columns will be shown as a row. This is what the transpose means. Now there is a shortcut method to do the transpose like I dot capital T. You can provide the capital T as a transpose and it will happen the transpose. Now see, all rows will be as columns. Now all columns will be as rows. Right? Can we change the shape of an array? Yes, we can change the shape of an array. Means flatten the array. What is meant by flatten the array? Means changing the shape of an array. Let's say there is a array B. Let me show you the array B elements like this. Now there is a two different rows it is showing, right? But I want to flatten it. Flatten means converting all rows elements into just only one row element. How do you do that? Using ravel method. B dot ravel method is there. Using ravel method, you can convert all rows into one single row only. All rows element into one single row only. Alright, very good. But can we reshape the elements? Reshape the matrix. Right? Reshape the array. But if we don't want to change the data, yes, we can do that. There is a, I think, array we created as G, right? This is the array G. We can reshape it using reshape method. G dot reshape, right? Let's create in the shape of 3, minus 2. I will show you why I write minus 2. Okay, so 3, 2 means basically 3 rows and 2 columns I want. Currently it is having 2 rows and 3 columns, but I want in 3 rows and 2 columns. Using reshape method, you can do that. See, the minus sign or minus 1, basically I multiplied it over here. So this minus sign, what it will do, this minus 1 will adjust internally, flatten the array. It is used to flatten the array and figure out automatically what shape it should take or what shape it should take while reshaping. So that's why we use a minus 1 to do it automatically. Alright, can we add or remove elements from an array? Yes, we can do that. Let me show you the array G first. This is the array G. Alright, let me, okay, before appending or removing something, let me show you the resize method as well. I think there is a resize method. Resize. Okay. This method resize, what it will do, you can give the size of it. Yeah. The resizing also happens. Resizing also happens using resize method. Okay. The append items to an array method, we call it as append method. np dot append method g comma h comma g, let's say. So what will happen? The elements from G will get appended to the elements of H. Likewise, right? You can append the elements to another array from some other array. You can insert elements using insert method like this. Let's say a np dot insert into the array A only. I want to insert 1 and 5. I want to insert 1 and 5. No. I want to insert 1 at element 5 at index 5. I want to insert 5 at index 1. So it is other way around. I want to insert 5 at index 1 in array A. See, at index 1, 0, 1, right? At index 1, the 5 gets inserted. You can delete it using delete method. np dot delete. There is a method called delete. From array A, give the index number and you can delete it. See, it will return the elements after the deletion, right? Can we combine the arrays? Yes, we can combine the arrays using concatenate method. There is a method called concatenate. np dot concatenate. Okay, you can combine two arrays. Let's say a comma b. There is method. Okay, around I want to combine it. X is equal to 0. So there is a sign. Okay, same number of dimensions. I think a and b does not have the same dimensions. So let me show you some other examples. There D. So D has the same dimensions. A and D has the same dimensions. So you can concatenate two arrays of the same dimensions, right? We can use np.vstack. np.vstack means virtual stacking. You can stack the arrays one on the other, on top of other, a comma b. Sorry, not a comma b, a comma d of the same dimensions. The array of the same dimensions can be combined together using like this. vstack means virtual stack. You can do the horizontal stacking as well. vstack, hstack, then there is a concatenate method, right? So you can do the combination of arrays like this. We will see about splitting arrays. As well. Alright then, let's go ahead and see some splitting of arrays. How do we split arrays in NumPy? Okay, so you know how our NumPy array A looks like, right? It has right now 4 elements as 1, 5, 2 and 3. Okay, let me split it at 2. Let me split it at this element, means at index 2, 0, 1, 2. Okay, how do we do that? np.h split of array A at index 2. H split means horizontal split. You can do horizontal split, you can do virtual split using vsplit. I will show you that as well. So see, the array A is getting split at index 2. So only 2 elements in the one array and 2 elements into the another array. Very good. Now let's do the vertical split at index 2. Let me show you another array of C. I think there is array of C, yes. And we can do the split, vertical split, np dot virtual split. The vertical split of array C at index 2. C. Now it is getting splitted at this index 2. There is a new array is getting created. Right, this new array. 2 different arrays getting created. if you see the brackets correctly, right? So this is how you can split the array: virtuals or horizontal splitting, vertical splitting, right? Very good. Now let's do some hardcore problems in NumPy that mostly get asked in experience level interviews or intermediate to hard level interviews. That the question is, can we convert pandas data frame into NumPy array? Can we convert some pandas data frame into NumPy array? Yes, we can convert the pandas data frame into NumPy array using a method called toNumpy, to_NumPy method. Okay, so let me show you the code. So this is the code to convert the pandas data frame into NumPy array using a to_NumPy method. Now see, I have created a data frame over here using this code, a random sample data frame, you can say, right? And I have printed the data frame, and using to_NumPy method, I converted its data frame into a NumPy array. Let me show you both. See, once you run these, once you execute these, this is your data frame, original data frame, right? And this is now your NumPy array. Now all your data frame is converted into a NumPy array. Can we convert a specific column to a NumPy array? Yes, we can convert the specific column to a NumPy array using like this. See, let's say I want to convert only columns B and C to a NumPy array. Columns of data frame B and C to a NumPy array. Yeah, we can do that. See, likewise using .to_NumPy method. Very good. This is a very good question and mostly asked in interviews. Now there is another question. They ask that do we know about the vectorization in NumPy? Do you know about the vectorization in NumPy, especially function vectorization? Let me tell you what it is. The function vectorization is a technique that is the function is applied to all elements of an array. Means, let's say I'm talking about any other function. Resize function, append function, minimum function, right? The square root function. There is these functions, right? So the one function applies to every element of an array is called the function vectorization, right? Now this function vectorization is very important in some computational operations, some arithmetic, computational, logical operations, by scientific computing. All right. So let me tell you one code, such code. So this is the code for function vectorization. Now I have write the definition over here to add elements of two different arrays. So this add function I have wrote. Now you can reuse this function multiple times whenever you want. So code reusability will be given over here. Okay. Now this is two arrays. Okay. You can call the vectorize method. On this add function to create a variable, a function variable. And using that function variable, you can pass the two arguments. As two arrays, array 1 and array 2, and you will get the addition between these two arrays, right? So 1 and 4 is 5, 2 and 5 is 7, 3 and 6 is 9, right? So elements of two different arrays getting added using this add method. So this is what happens, that this function is getting applied to each and every element of an array. This is called function vectorization, right? All right. Now there is also a very good question that mostly experienced level interviewers get asked, that do you know how to find the local maxima or local peak of 1D array in NumPy? Do you know how to find the local maxima or local peak in 1D array of NumPy? Yes, there are 2 to 3 methods that we can do it, but there is a very famous method called where method, in which you have to do some tricks to find the local maxima. Let me show you the code. So this is the code to find the local maxima or local peak of a 1D NumPy array. Now this is the 1D NumPy array as a sample I have given, inside which you have to find the local peak. Peak means the maximum value inside 1D array. How many times there are some maximum values occurred? So see, I can see the 19 is a maximum value, 6 is a maximum value, 5 is a maximum value, 8 is a maximum value, right? And all other values are just lower in size. But at this 4th position or 4 indexes, I can see the maximum value. So let me print those indexes. Using where method, I can go and find by doing this process. Now, what I did over here is a little hard to understand. To understand it, let me show you in a very short manner. What we did, we have this array created, ARR, right? So we created another array, we call it as a shifted array, left shift and right shift, okay? So by left shift and right shift, we compared the elements of these two arrays. We compared the elements of these two arrays. After comparing the elements of these two arrays, what we did, we used the where method, diff method and sign method under the hood. Okay, combination of these two methods, and find out the indexes at which it is maximum. And it will return the arrays. It will return the number of indexes in an array. So I want the 0th index. So it will give me all the points which are at the peak. See, it will give me the indexes points of local maxima or peak values. Right? It is little, we can say, hard to understand, but this is how it works. This -1 to 1 or 0 to -2, what it happens over here is that it is selecting the left shift or right shift of arrays. So this is what it is happening. Now, one more concept I want to just cover over here is called broadcasting. What is broadcasting in NumPy? Okay, so this is very, very important when you do function vectorization. So broadcasting happens before function vectorization. What is broadcasting basically? Broadcasting nothing but it solves the problem of mismatched shaped arrays by replicating the smaller array along the larger array. Why? To ensure both arrays having the compatible shapes for NumPy operations. Means, let's say you are doing some arithmetic or NumPy operations on two different arrays, and one array is larger than another array in size. Okay, so the operations can't perform. So to perform this operation, both the arrays have to be of the same size. So broadcasting comes into picture. It makes both the arrays of the same size. Okay, by performing broadcasting before vectorization helps to vectorize the operations. Okay, to help the vectorize the operation which supports arrays of different dimensions. All right. So this is what called the broadcasting. Let me just write this term, broadcasting. Broadcasting arrays. Okay. There is another concept that I supposed to tell you in basics of Python only, but no problem. I will tell you right now. It is called pickling and unpickling of an elements. Pickling and unpickling. Let's say you have some data sets and you've done some analysis on it, and you want to store your task or your analysis into some file. So you can pickle that analysis and store into the file. And next time when you come back to work, you can use that analysis from stored file and load it into your calculations. So you don't have to start from scratch. This is what the pickling and unpickling is. Pickling means serialization, data serialization, and unpickling means unserialization, right? So it can be done using dump and load method in pickle. So let me show you some code for it. Okay, pickling and unpickling. Pickling and unpickling. Okay. See, now I have written the code for pickling and unpickling. What you do, I have a sample dataset of tips. This is a flower. The tips dataset you will get into Seaborn. Okay, the Seaborn library. I have also imported the pickle library from Python. Okay, pickle and Seaborn. I will tell you about Seaborn in detail later on. All right. So there is a tips data frame, and you can load the data frame into the disk using dump pickle.dump method. You can load the data frame in write bytes mode. This is the format. Write binary mode. Okay, and once it is stored, you can use it anytime you want. Once it is stored by the name of the file name is demo.pickle. You can use that file name to load it anywhere else as well. And that analysis will be loaded using pickle.load method. In write, not write. Now it is read binary. Mode. Okay. So you can do that and you can show the data frame that you stored. Okay. Right now here I haven't done some calculation. You can do some calculations on this data frame, and those calculations will be stored into this demo.pickle file, and you can use that demo.pickle file by loading it back from this stored file to your calculation window, right? So this is what we wanted to see for NumPy and NumPy arrays, all the calculations, demos, right? Some arithmetic operations, sorting, comparison, initializing, placeholders, right? For scientific calculations and all. So this is the NumPy cheat sheets, which is mostly useful for data analysis and data science purposes. I hope you liked it. Please do share this video and comment down below and let me know how you are doing. Please subscribe as well and do join my WhatsApp channel. The link will be in the description down below. Till then, peace out.
Goo gaga. ये लड़की मेरे सामने मेरा दिल ये जाए जाए जाए